The theory of every string. I mean, everything. String theory has its roots in something called Collison theory, which was developed in the 1920s to unify gravity and electromagnetism, but quickly lost credit among the physics community when it was discovered to be deeply flawed. Decades passed, and it wasn't until the 1970s until Collison and eventually string theory emerged as a mainstream candidate for the theory of everything. If this pillow represents quantum mechanics and this pillow represents relativity, then trying to fit them together looks something like this. As you can see, there's no possible way to orient the pillows so that they fit inside the box. A bigger box, or bigger theory, is needed. String theory provides enough room for both quantum mechanics and relativity, which is one of the reasons it's such a major candidate for the grand unified theory of everything. So what is string theory really? Well, it states that A. We live in a 10 or 26 dimensional universe. These extra dimensions are buried deep within the mathematics of string theory, which basically states that besides the 4 observable dimensions that we have, there are also 6 or 22 other dimensions which are curled up and thus unobservable. If I hold up a rolled up tube of paper from all the way over here, it just looks like a line or a one-dimensional object. Thus, the second dimension is concealed or curled up. But as we get closer, we start to see that what previously looks like a one-dimensional object is actually a rolled-up two-dimensional object. B. Matter is made up of tiny vibrating strings. This essentially means that if we went down to a subatomic level and then kept zooming, we would eventually reach a tiny vibrating string instead of a point particle. C. The different particles that we observe can be thought of as different notes on a stringed instrument. This part explains why there are so many different particles predicted by quantum mechanics. Think of it this way. If you have a stringed instrument, you can play tons of different notes. So if you have a string, you can have tons of different particles. Proton! D. At extremely high energies, the 4 forces are unified. String theory predicts that at high enough energies, say if we superheated a gas to ridiculously high temperatures, the 4 fundamental forces of nature, gravity, electromagnetism, and the weak and strong nuclear forces, would become unified into one big superforce. There are many different types of string theory, including bosonic, type 1, type 2a, type 2b, heterotic open, and heterotic closed. As physicists discovered more and more of these string theories, the theory itself got more complicated instead of simpler, morphing from a nice self-contained model of the universe into an overcooked mass of string spaghetti. But don't worry, M-theory came along to solve all those problems. Scientists realized that all of the different string theories actually have a lot of common elements, and so condensed them into this theory currently known as M-theory. M-theory retains all of the good qualities of string theory, except it postulates that matter, instead of being made up of tiny vibrating strings, is actually made up of tiny vibrating membranes. To illustrate this, consider this straw. From far away, it looks like a one-dimensional object, or a string. But if we were to unravel it, you would see it's actually a rolled-up membrane. String theory can only be applied to one-dimensional objects, closed or open strings, whereas M-theory can be applied to a host of multi-dimensional membranes, which makes it more versatile. There are 2 main types of membranes in M-theory. P-branes. The P in P-brane stands for a number, which corresponds to the number of dimensions an object has. So, for example, a 1-brane would be a string, a one-dimensional object. And D-branes, which are a specialized subset of P-branes and correspond to a group of membranes whose members, strings, ends lie on the same plane. Despite all of its successes, string theory still has some major shortcomings. The first is that string theory, as it stands now, is actually unsolvable. Our mathematics are just not advanced enough. In order to solve string theory, we'd have to develop a new form of mathematics, a lot like how Isaac Newton did with calculus. The second problem is that string theory is experimentally untestable. The high energies required by the theory to unify the 4 forces in matter are far larger than anything we can possibly generate on Earth, which makes experimental verification out of the question. Although flawed, string theory and M-theory are among the strongest candidates for a theory of everything, which would unify quantum mechanics and the theories of relativity, giving us a much more powerful tool to look at the universe. A way to look into aspects of the universe previously unknown to us, like black holes, from the comfort of our own living rooms, without all that nasty spaghettification business. A unified theory of everything might be the first step in mastering space-time itself, which opens up a host of other interesting possibilities, like travel between planets, between stars, and even between universes. Pretty interesting, don't you think?